All right, so we are going to do a lesson on polynomial arithmetic. So, fancy words, polynomial. In parentheses, I have one polynomial here. I have another polynomial here. A polynomial is a sum of monomials. So, I've got the monomial 5x squared. It's a monomial because it's a product of a coefficient constant number 5 times x to some exponent, in this case 2. Here's another monomial, 2 times x to the first. Here's another monomial. This is 2 times x to the 0. We don't have to write x to the 0 because any base raised to the 0 power is 1. And so similarly over here. So we've got a polynomial. We're going to add it to a polynomial. This happens just like regular addition does, so let's consider 532 plus 147. If we were going to add these two numbers, you see we've got three place values, hundreds, tens, and ones, plus hundreds, tens, and ones. So traditionally we would write this in columns with place values lined up. So we've got 532 plus 147. We add the ones. 2 plus 7 is 9. We add the tens. 3 tens and 4 tens is 7 tens. We add the hundreds. 5 hundreds and 100 is 600. We get our total answer, 679. All right. Now, the only difference between adding regular old numbers in base 10 and polynomials is that instead of base 10 where we have x, our base being 10, we would have x being unknown. We don't know what our base is. In this case, we had 10 to the 0, which is ones, 10 to the first, which is tens, and 10 to the second, which is 100s, hundreds. Okay, so up here, we don't know what the base is. It's x. It could be anything, but x to the 0 is ones, x to the first is x, and x to the second is x squared. So we're going to line up each of those x's raised to various powers as though they're place values, because that's really what they are. All right? So we're going to combine like terms. You've probably heard that as well. So we're going to set this up in columns. We'll rewrite our first number, 5x squared plus 2x plus 2. I called it a number, but I should call it a polynomial. Here's our polynomial. We're going to add the second one, lining up like terms. So 3x squared below 5x squared, 4x below 2x, and 7 below 2 wholes. We're going to add those. All right, so we get 2 wholes and 7 wholes is 9 wholes. 2 x's and 4 x's gives us 6 x's. And 5x squareds plus 3 more x squareds is 8x squared. So here is our final answer for this polynomial addition. We get 8x squared plus 6x plus 9. Again, all we did was line up terms that have the same base, okay? These are wholes, so I can add them. They're the same kind of thing. These are x's, so I can add those. They're the same kind of thing. And these are x squared, so I can add those. They're the same kind of thing. And we're done.